I'm conducting an experiment to see if angle affects the distance of projectile being launched from this rocket launcher right here. My hypothesis is that 135 degrees will have the maximum distance of the projectile, because I'm thinking if any higher, it'll waste energy going up, and any lower, gravity will take over, and it will skim the ground, reducing the distance. The tools I'm going to be using are this big protractor to measure the angle, this 25-foot tape measure to measure it, and then this notebook to record my data. And then I'm going to be using this rocket, the atomic firebomb.
And tell us what your PSI is going to be.
The PSI, pounds per square inch, is going to be 15 PSI. We've done some testing before the video to test how much PSI we're really going to need, and we lowered it down to 15. We started at 30 and it hit the ceiling. And then we went down to 20. It hit the ceiling. 15 seems to be the right amount. My first angle I'm going to start with is going to be 90 degrees. 90 degrees exactly. I'm going to be doing 3 trials at 90 degrees and 3 trials of the other 2 angles. Firebomb at 90 degrees in 3, 2, 1. Right now, it landed almost exactly at 27 feet. I'm going to record that. This is trial 2 at 90 degrees. We will be beginning in 1.
Ooh, back here this time.
We are going to redo take 1 on 90 degrees because we realized it was up against the wall exactly. It's not right now, it's just free hanging. And we want all variables. We want no variables in our testing. We want exact data. This is going to be trial 1, take 2. In 3, 2, 1, go. Like this recording is going to be 19 feet and 7 inches. This is going to be my next angle, 110 degrees. This is going to be our first test on 110 degrees in 3, 2, 1.
Oh!
It looks like, from the tape measure, it landed on 48 feet and 6 inches.
What you're doing?
Right now, we're testing it at 130 degrees, take 1.
Yo.
This is going to be our first test on 130 degrees. 3, 2, 1. On 58 feet and 9 inches. Thank you, Mom. This is going to be take 2, trial 2 on 130 degrees starting in 5, 4, 3, 2, 1.
Okay.
It looks like, according to my mom, that this is 58 and 3.
Go.
Our final angle is going to be 150 degrees. I'm expecting it's not going to go as far because it's going to be almost straight upward and it's going to lose a lot of energy and velocity doing that.
Go ahead.
It looks like this is 4311. 43. This is going to be 150 degrees, number 2. In 3, 2, 1.
Okay. Go.
Take 3. The end of the atomic firebomb. Here I am, back in another day to calculate the averages of the distances we recorded in the gym. These are my distance is on 90 degrees, 19 feet, 7 inches, 24 feet, 10 inches, and 22 feet, 11 inches. To figure the average, what we did first is we converted the inches into a decimal by dividing them by 12 because there are 12 inches in a foot. For 19 feet and 7 inches, we came up with 19.583 feet. For 24 feet, 10 inches, we came up with 24.83 feet. For 22 feet, 11 inches, we came up with 22.916 feet. The next step to figuring the average is adding those together. And it turns out those 3 added together equals 67.329. Now the last step to figuring the average is, since there are 3 numbers, we need to divide it by 3. And we came up with 22.443 feet, which converts to 22 feet and 5 inches. Right now, we have figured all the averages for the projectile distances. First is 90 degrees, right here. The average is 22 feet and 5 inches. Next is 110 degrees. Its average is 49 feet and 5 inches. And then comes 130 degrees. Its average was 59 feet and 5 inches. And then last comes 150 degrees. Its average was 43 feet and 2 inches. My hypothesis is that at 130 degrees, the projectile would have the farthest distance. And that was now proven correct because it has the highest average of all the data right here. As a scientist, even if your hypothesis is proven incorrect, it is still okay because you still learn something and you can make adjustments for next time. Thank you for viewing Angle Affecting Projectile Launch Distance. Over and out.